So this is the lab about momentum and energy. This is how you rig up the cup. Make sure that you put duct tape on there so that it catches the foam that you shoot in there. You may not have the luxury of using a board like I do, but you have to do it somehow. I usually make a mark behind the cup, and then I'm going to measure how far it goes out. So here we go. I'm going to shoot it in there. And ideally, this should be done with two people. One person shoots and the other one measures. Well, puts the mark on the wall that you cannot wash off. And I'll do this 3 times. You may want to do it 4 or 5 times to get a good average. So somewhere in there, and then this here would be the distance D that you have to measure. Notice, do not measure the angle because you use that distance D in order to calculate the angle. What else you have to measure here is the length of the pendulum. So length of the pendulum, which is from the pivot point here, in my case, the bottom of the tape, to the middle of the cup. This makes sense because the cup swings at its center of mass, not at the bottom, not at the top, but the middle of the cup. So you have to measure length, you have to measure this distance here, the average distance. You have to determine the mass of the foam darts. Oops, this one just fell off. Mass of the foam darts. I think I just call it MD. And the mass of the pendulum itself, or the mass of the cup. Pendulum cup. Okay. So primarily what I want to show here is how you measure the distance here, and what you need is to make yourself a mark here. And you're not going to have the convenience of using a board like I do, so you have to figure out how you do that. Put it relatively close here and then shoot it in there. And then you see how far it swung out, and that would be the back of the cup. I'm doing this by myself here, so you may want to have somebody else who can look at that better and make the mark while you shoot. And I'm going to do this 3 times here. You also notice that I have a lot of duct tape on here, that's on here, so that the foam dart doesn't come out. If it did, it would upset the measurement. There, okay, that's good enough. The distance here, take kind of an average, so this distance here is what you would measure in centimeters. Put it into the equation, and then the equation will actually determine the angle. So remember, you're not measuring the angle here, you're measuring the distance that it.
This recording is for determining the angle. Let's assume that we have a pendulum length of 74 centimeters and it goes out by 11 centimeters. So according to the guidelines, we use the equation of the inverse tangent of 11 over 74, and we come up with a rounded 8.5 degrees. We can use another calculator. So here I'm going to do it step by step. 11 divided by 74 equals. Then I'm going to take the inverse tangent, in this case it's called a tangent, of 0.1486486. And notice that's not the same number as we had before, because this calculator is in a different mode. It's in radians instead of degrees, but that's easy to fix. I'm going to take that same number here, 0.14758, multiply it with 180 and divide by pi, because it's a conversion, and there's the 8.5 degrees. The third way of doing this is to actually use tables, and keep in mind our original calculation, 11 divided by 74, which was the 0.1486. And here I looked up this table. All I did is I googled table tangent, and I came up with this. And remember that our number was 0.1486, which means we're kind of in here in between the 8 and 9 degrees, and we can say, well, that kind of is in the middle here, so let's just call it a rounded 8.5 degrees. And that might even be, here looking at this table, be the easiest method. I have posted the website address for this one here respectively. It should be relatively easy to find that as well. That way you get around using the calculator in this case. This recording is for determining the velocity according to the ballistic pendulum method. And again, I'm going to make up numbers. And I'm on this graphing calculator, I'm going to just do an entire equation in one big swoosh or swoop. 15, I just make this up here that the pendulum mass is 15.4 grams plus the foam dart 1.1 grams. Again, I just make up my own numbers here. Divide by 1.1 because it's important for me to show that how to do it on the calculator rather than using correct numbers, and that's what you're going to come up with in your measurements with your own correct numbers. These are of course just examples. So square root of 2 times 982, you're likely to be in Alaska and we're measuring in centimeters, so it's 982 times 1 minus the cosine of 8.5 degrees, and then I'm going to close all these parentheses. I'm going to come up with something that's wrong. But the nice thing is about doing it in one big equation here that it's easy to correct, and that's what I'm going to do now, which means this has become really instructive. I forgot about the length to put in there, and on a graphing calculator like this, second entry, go up, and right there is where I forgot about the length, which was 74 centimeters. And I come up with 599 centimeters per second. I divide that by 100. Enter. 5.99 meters per second. Let's do this on a different calculator with the same numbers. So here I'm going to have 15.4 plus 1.1 divided by 1.1 times square root of 2 times 982 times 74 times parentheses 1 minus cosine of 8.5 degrees, parentheses, hit enter, 599 divided by 100 of course, 5.99 meters per second. Of course that will be around at 6.0 meters per second. Let's do it for a third, with a third calculator. This one here, that's also the one that doesn't give us degrees but instead just radians. I'm going to do, and here we're just going to do it step by step. I really, for myself, I really prefer to do it in all one big thing, and then, because then it's easy to go in, to go and fix if I did something wrong, and you have seen that. So here instead I'm going to do it step by step, and I'm going to start within the square root first. I'm going to do 1 minus cosine of 8.5 degrees, but remember this one here doesn't do degrees, so I have to convert it to radians, and I do that by, this time around, times pi divided by 180 degrees, parentheses, equals. Now here when I do it one step at a time, I actually have to jot down my intermediate result. So 0.010984 is what I'm going to write down. As before, I could also use a table if I don't want to use the cosine and convert it. So here's a table. Remember, we have 8.9 degrees, 8.5 degrees. So I'm in the middle between these two here, 0.9903 and 0.9877. So I come up with pretty much 0.9890. And so I'm going to go back to the calculator, and I'm going to do 1 minus 0.9890. Remember, this is for if I don't want to do the cosine, but I just want to use a table. I hit equal, and I come up with the same result. 0.011 is the same as 0.01098 because of the significant figures that we're going to use for our measurements. Okay, now it's going to be, I'm still inside the square root, 2 times 982 times 74 times 0.011 equals, and again I have to jot this down perhaps, 1599. I take the square root of that number, 1, 5, and a rounded 99. Oops, I guess I have to close the square root, the parentheses here. I come up with a rounded 40.0 actually. Again, I have to jot that down. Now I'm going to do the two masses, which is going to be 15.4 plus 1.1 parentheses divide by 1.1. Come up with 15, multiply that with my rounded 40.0, and come up with the same thing as I had before, where I had 599 respectively, a rounded 600, and I divide that by 100, and I come up with 6.0 meters per second. Just like earlier, I had 6.00 meters, 6.0 meters per second. This recording is for the kinematic analysis for this lab. Let's assume that we have measured a distance of 390 centimeters, an average distance, times the square root of 982 divided by 2 times 100. By the way, I'm making a mistake here on purpose to show you a typical mistake. I come up with 86,000 centimeters per second. That's not even remotely close to the other method. Of course, the two methods, they should be relatively close, but this is way, way off. What have I done wrong? Well, I'm supposed to put the denominator in parentheses, because what I have done the first time around was I multiplied with the 100, while when you look at the equation, I'm supposed to divide by 100 because it's in the denominator. So I have to put that parentheses around there. And now that looks better. That's still quite some error in there. 864 centimeters per second, or 8.6 meters per second. That's still a 40% error, but that's what I said in my instructions, that you could expect to have a 20 to 50% error there, but not what I had a moment ago, where I actually plugged in the wrong equation. And here I wanted to show you how you can fix that and how you can take care of that. On another calculator, this may look like this: 390 times the square root of 982 divide by parentheses 2 times 100 parentheses enter, and there again is 864 centimeters per second, or 8.6 meters per second. And yet on another calculator where I don't do it in one big swoosh, but I'm just going to do it step by step. So I'm going to do 9.82 divide by parentheses 2 times 100. Notice already that I did put a mistake in here. I come up with 0.0491. I have to jot that down because I'm doing this step by step. Reason I put that mistake in here, the 9.82, is to show another typical mistake that could be made. In any case, I have to take the square root of 0.094, whoops, 491. There we go. I come up with 0.22, 15, or 16. Again, I have to jot that down, and now I'm going to have 390 times 0.2215. Oh, I don't need it that accurate. 16. And I come up with 86.4, which is kind of centimeters per second, or 0.8 meters per second, which is kind of like 100% error. I didn't say it would be that much, but you saw the obvious mistake earlier. Instead of 982, I used 9.82. In this case, it's not too bad. I just need to shift it by 1 decimal point. So multiply this by 10, 860 centimeters per second, and then of course divide by 100 to come up with the 8.6 meters per second, which again is at 40% error in my measurements. The times 10 here a moment ago was just to fix the mistake that I had made earlier. In order to do the whole thing here, to do it right, I would have to actually start completely over 982, divide by parentheses 2 times 100. And that makes the other method to do it all at once really nice, where I can just go in there with the edit and on the other calculators and just fix that error here. I have to do everything over again. 390 times 2.21. See, I made a mistake there too. 2.2156, and I come up with the 864 centimeters per second, or 8.6 meters per second. So overall, I showed you here how to do it on 3 different calculators. I also showed you what typical mistakes are that you could make, that you should avoid, or if you have them, how to fix them.